All right, Marcel, I thought I would go over this question about partial pressures. And I thought I would record it, it'd be a lot easier. Okay, so what we have in this example is a tank with a volume of 5 cubes, half full of water, half full of air. We are not open to atmosphere. Okay, so we have water here. We have 2.5 cubes of water. We have air up here. And we have 2.5 cubes of air. Okay, 40 degrees C. Partial pressure of the water is that. What is the mass of the air? Okay, first thing we need to understand is that it's a very misleading question. When they're talking about water, there's water and there's air and water vapor. So air is made up of 2 components, which is dry air. This is why this question is so misleading. Plus water vapor. Both of these are gases. And that's why this question is so misleading. So, since they're both gases, Dalton's law of these partial pressures works. So if we look at this section up here, we have air and we have dry air and water vapor. So therefore, Dalton's law of P total equals the partial pressure of the dry air plus the partial pressure of this water vapor. What do we know? What are we given? We're given the P total we know is atmospheric. Tank with volume contains air at 40 degrees in atmospheric. So we know this. Dry air, that's what we're trying to find. And we know the water vapor, partial pressure of the water vapor is 7.3184, yes. So I guess you guys should be asking, like, okay, Mike, why am I trying to find this dry air? Because we're asked the mass of the dry air. Why do I know we need that? Well, it's an ideal gas, and we're going to use the equation P dry air V dry air equals the mass of this dry air times the gas constant of this dry air times the temperature of this dry air. So why do I know we need this P dry air? I need it for this equation. So let's go ahead and figure it out. We're going to have to rearrange this equation to solve for P dry air. That equals the P total minus, I just subtracted P water vapor from both sides of the equation. P water vapor. This equals P total 101.3 kPa, which is atmospheric. I always write down my units, otherwise I screw things up. And the partial pressure of the water vapor with way too many units is 7.3814. 7.3814 kPa. 101.3. 7.3114 minus. That gives us 93.9, roughly speaking. Always follow up with our units. Oops, I'm running out of space there. That looks like garbage. Let me fix that for you guys. 93.9 kPa. 93.9 kPa. Okay, we need to remember that. We because it's our P of our dry air. So I also need, what do I know here now? I know this, I just calculated it. I always know that a gas will expand to the full volume it has. So the volume of the dry air in there is 2.5 cubes. The volume of the water vapor in there is 2.5 cubes. Those gases will actually mix and they occupy the same volume. You don't divide it by 2. So that's kind of a tricky part that you need to know. They gave us this and they gave us this. We need to watch our units, but first let's rearrange this equation. If I divide by RT, both sides of the equation, I will get mass of the dry air equals, let me rearrange this here, P of the dry air, V of the dry air, which is the volume of course, divided by R of the dry air, times T of the dry air. Okay, the pressure we just calculated, which is 93.9 kPa, again, always putting in my units, times the volume, which we went through, is 2.5 cubes, divided by the R, which they gave us. This is where the units start to get tricky. 0.287 0.287 kilojoules per kilogram K. Now that's degrees Kelvin, so that should give us a big clue here. We're 40 degrees Celsius, but in order to take it to the Kelvin scale, we need to add 273. This equals times 0.287, that gives us roughly 2.6 kilograms. What did these guys get? Same thing. So I hope you guys understand this, Marcel. A couple things you got to remember for this. You've got to remember the components of air are dry air, which is a gas, water vapor, which is a gas. They will both fully expand to occupy this space. Intermixed, so you don't divide it by 2. They will mix. The molecules will actually mix in between each other. You need to know that the partial pressures, well, by knowing this water vapor, you don't confuse the water in the tank. It's a very misleading question that way. It's worded pretty poorly. When they give that R up in a question, R for air, that they should actually be listing that R for dry air. What else do you need to know? That's about it. Watch your units. Kelvin, you simply add 273. We're all in kilo, top and bottom, so everything else crosses out. I think that about covers it. Please send any more questions my way, and I'll take you guys through it. Take care.